Now in this video lecture we will go through the discovery of electron, right, and we will go through the experiment that lead to the discovery of electron, right, which is one of the subatomic particle of an atom, right. So this experiment, right, was carried out by William Crook in 1879, right, and what he was doing is he was studying the conduction of electricity through gases at low pressure, right. So this is your this experiment was carried out by William Crookes in 1879, right, where he was studying the conduction of electricity through gases at low pressure, right. Conduction of electricity through gases at low pressure, right. Now this was the setup of the experiment, or this is an experimental arrangement which William Crook used, right, to study the conduction of gases at to study the conduction of electricity through gases at low pressure, right. What he did, this is a tube, right, which we call it as a discharge tube, and at the side of this tube you will see one side tube, this side tube is further connected to a vacuum pump, right. This side tube is connected to a vacuum pump, right. Since we said that William Crook was studying the conduction of electricity through gases at low pressure, right, so in order to maintain low pressure of the gas inside the discharge tube, we need to remove the gas from inside the tube, right. So this vacuum pump will help us to remove the gas from inside the tube, right. So vacuum pump will pump out the gas from inside the discharge tube, thus lowering the pressure of the gas inside the tube, right. So we also call this as Crooks tube, Crooks tube, right, because William Crook used these tubes, used this experimental setup of tubes, so these are also known as Crooks tube, right. So now just look at the experimental setup, right. This is a battery, right. Negative terminal of the battery is connected to the cathode, this is cathode, right, and positive terminal is connected to this material, this is anode, right. So the terminal connected to the negative, negative terminal connected to the cathode, and positive terminal simple connected to the anode, right. Now what William Crook did, right, the first thing he did was he noticed that no electricity flow. What he did is he studied the conduction of electricity at different pressures, right, and he kept lowering down the pressure of the gas inside the tube, right, and observed the flow of electricity, right, with the decreasing pressure, right. So here flow of electricity was observed with decreasing pressure, right. Now let's see the observation at various values of pressure, right, observation of flow of electricity at various values of pressure when the pressure was normal pressure, which is 1 atmosphere, right, no flow of electricity, was observed, right? Why no flow of electricity? The simple reason is that gases are poor conductors of electricity. So when there was too much gas inside the discharge tube, no current flow was observed because gases are bad conductors of electricity. No current flow because gases are bad conductors of electricity, right? Now if you just want to look more deeper into it, why electricity did not flow, right, at high pressure when the gas pressure is high, we know that electricity is nothing but the flow of charge, right, or electricity is the flow of electrons, right? When there were too many gas molecules, the gas atoms or gas molecules, whatever, inside the tube, right? So when these electrons, when you apply high voltage, right, electrons would be emitted by the material of the cathode. This is the material of the cathode, right? So the electrons emitted, right, by the material of the cathode would collide with these gas molecules, right? So these gas molecules will produce hindrance in the flow of electrons, right? So there is very less flow of electrons. So less flow of electrons means less or no flow of electrons at high pressure, right? Very less or no flow of electrons at high pressure because these electrons collided with the gas molecules or gas atoms, and hence the gas atoms were providing hindrance, right? Gas molecules or gas atoms were offering or providing hindrance in the motion of electrons, right? So no motion of electrons means no flow of electricity, right? This was the reason. So if you want to write it, at high pressure, gas atoms, right, offers obstruction to the flow of electrons, right? So when there is obstruction to the flow of electrons, no electrons are flowing, that means no electricity, right? Because electricity, we know, is nothing but the flow of electrons. So this was the reason why there was no electric current flow at high pressure of gas inside the discharge tube, right? Now let's look at the second point. What William did, he lowered the pressure. What he did, he lowered the pressure of the gas, right, inside the tube with the help of vacuum pump to 10 to the power of minus 2 atmospheres, right? With the help of this vacuum pump, he pumped out gas from inside the discharge tube, right? Thus, when the gas is pumped out of the discharge tube, the pressure of the gas inside the discharge tube is reduced, right? When we say the pressure of the gas is reduced, what we basically doing is we are just reducing the quantity of gaseous atom inside the discharge tube, right? So when the pressure is lowered to 10 to the power of minus 2 atmospheres, right, with the help of vacuum pump which is connected to the side tube, right, then it was observed that the electric current started flowing, right, and it was observed that the electricity begins to flow and light is emitted, right, when the pressure is lowered to 10 to the power of minus 2, right, and here the voltage that is applied was around 10,000 volts, right? Voltage applied was 10,000 volt and pressure now is your 10 to the power of minus 2. Pressure, the value of pressure is reduced compared to 1 atmosphere, Now at low pressure, flow of electricity was observed, right? Flow of electricity was observed at this less, as 10 to the power of minus 2 atmospheres, which is less pressure, at reduced pressure. And you will also observe a glow of light, right? Or what we say is that at low pressure, light is emitted. So inside the discharge tube, you will see that some kind of light is emitted. Now what could be the reason for this light emission? And light is emitted inside the discharge tube, right? So if you just try to understand from this point, right, when the gas atoms were too much, when the quantity of gaseous atoms was high inside the discharge tube, right, and these electrons that were emitted from the material of the cathode on applying high voltage, right, these electrons were colliding with these gaseous atoms, right? So these gaseous atoms was offering obstruction to the flow of electrons, hence no flow of electricity. But when we reduce the pressure by reducing the gaseous atom inside the discharge tube, right, we noticed that electricity started flowing inside the discharge tube, right, or flow of electricity was observed, and there is also emission of light which was observed. What could be the reason now? Now when we suppose this is your material of cathode, right, that is emitting your electrons, right, and now we have less gaseous atoms, right? When you have less gaseous atoms, when we have less gaseous atoms, that is less obstruction to the flow of electrons that are emitted from the material of the cathode, right? So at low pressure, at low gaseous pressure, the obstruction offered to the flow of current is less. When the obstruction offered to the flow of electron is less, we have measurable, or we have good amount of flow of electrons. So flow of electrons means electricity, right? That is why at reduced pressure we observe the flow of electricity, because the hindrance or the obstruction offered to the flow of electron was less compared to the obstruction offered at high pressure, right? So this was the reason that electricity started flowing, because now electrons have started flowing or moving, right, without collision with the gaseous atoms, right? So flow of electricity was noticed because electrons were flowing or moving without collision with gaseous atoms. Now what could be the reason for this light emitted, right? From where this light is getting emitted? Now when the electrons, right, when these electrons, right, will strike or will collide with these gaseous atoms, right, what they will do is, when these high energy, since these electrons have high energy because we have a high voltage applied, right, so these gaseous atoms, these electrons from the cathode will move at a high speed, right? So these high speed moving electrons will collide with the gaseous atoms and hence will excite them. So when these gaseous atoms are excited by bombardment with fast moving electrons, light is emitted, right? So light is basically emitted from the gaseous atoms when on bombardment with the high speed electrons, right? So the emission of light, the reason emission of light was due to bombardment of gaseous atoms with high speed electrons. With high speed electrons, right? When these high speed electrons will collide with these gaseous atoms, right? Or when these high speed electrons will bombard these gaseous atoms will get excited. When these gaseous atoms will get excited, they will emit light, right? And the color of the light emitted will depend on the nature of the gas or which gas you have taken, right? Neon, if you suppose you have taken neon gas, the neon gives reddish orange color, right? Suppose in this discharge tube you have taken neon gas, so neon gas on bombardment with these high speed electrons will produce orange color, right? Or it's not orange, I'm sorry, it's reddish orange color, right? So neon will produce reddish orange color on bombardment with high speed electrons, right? So this was the reason for the emission of light and the flow of electricity at low pressure, right? That is why we say that gases are at low pressure are good conductors of electricity, because of all these reasons that I have explained, right? Now the third point is, if the pressure is further lowered to 10 to the power of minus 4, right? If pressure is further lowered to 10 to the power of minus 4. Now when the pressure is further lowered, basically what we are doing is we are further reducing the number of gaseous molecules inside the discharge tube, right? So the emission of when you further reduce the pressure, right, to this value, right, at this value the light emitted, right, by the gaseous atoms will stop, right? The emission of light by the gas stops, but the current continues to flow, right? And so if the pressure is further lowered, that is on reducing the number of gaseous atoms further in the discharge tube, the observation is the emission of light will stop, right? And the second observation was flow of electricity will continue, right? Flow of electricity will continue. Now what could be the reason for this stoppage, right? Stoppage of the emission of light, because we have said we have discussed in the second point that the light emission was due to the bombardment of gaseous atoms by the high speed electrons. Now when you have further reduced these gaseous atoms, we have very less gaseous atoms, so very less of few bombardments, so due to which the emission of light will stop, right? Because there are no or very few gaseous atoms, right? So no emission of light, and flow of electricity will continue because now these electrons, right, due to less gaseous atoms will flow at a high speed, right, thereby creating electricity, right? Thereby, I mean, the flow of electrons we know is nothing but electricity. So now electrons would be able to move more freely because there are very less gaseous atoms. So very less gaseous atoms means very less collisions, right? So less collisions means more flow of electricity, right? So flow of electricity will continue or will it will increase, and emission of light will stop because emission was due to the excitement of gaseous atoms by the high speed electrons, right? So this was the experiment, right? And since we said that the flow of electrons will continue, the flow of electricity will continue, and if you look at this is the anode, right? this is a perforated anode that has these holes in it, right? Perforated means it has holes inside it. When these, what you will observe is nothing is observed. These flow of electrons cannot be observed, right? So at low pressure 10 to the power of minus 4, you will observe that there is a greenish color, right, at this end of the glass tube, right? So what we say is that the glass wall behind the anode, right, the one that I marked with green, that's a glass wall behind the anode, will begin to glow with a greenish light. That is why I've made it with a green color, right? So what could be the reason for this green light, right? So it was it's mainly, you might have studied about this some phosphorant or fluorescent material, right? What they do is when light falls on them, they start glowing, right? So here the tests soon revealed, right, that this greenish light was due to bombardment of glass tube, right? Glass tube has atoms, right? So when the electrons that are coming from cathode, right, these electrons that are coming from cathode, they will pass through these holes in the anode, right? When they will pass through this hole, they will strike this, this tube at this point, right, and they will produce, or they will form a greenish glow, right, a faint greenish light, right? A faint greenish light would be produced at this end, right? So later it was observed that this faint greenish light was due to the invisible rays, right, that are coming from the material of the cathode. And since this is a perforated anode, so these rays, right, these invisible rays will pass through this perforated anode and will strike the glass tube at this point, right? So the greenish color that you see here is due to the bombardment of glass tube atoms, right, by these invisible rays, right? These invisible rays are called cathode rays, right? Why? Because these invisible rays are moving from cathode to anode. Since they are moving from cathode to anode, these are called as cathode rays, right? And these cathode rays are nothing but beam of electrons, right? These cathode rays are nothing but cathode rays. We call these cathode rays as beam of electrons, right? Since we know that these electrons, we have been discussing all through this experiment, that the electrons, right, that are emitted by this material of cathode will bombard with these gaseous atoms, right? So these gaseous atoms, right, these gaseous atoms earlier we know that was offering obstruction to the flow of electrons. That is why there was no current, right? So these beam of electrons, when there was very less gaseous atom inside, these beam of electrons or cathode rays will pass through this perforated anode and will strike this glass tube at this point, producing a greenish faint color, right? This greenish faint color, now we know, was due to the bombardment of these glass tube atoms, right, by these beam of electrons, right? So cathode rays is nothing but a beam of electrons. Since they are moving from cathode to anode, we call it as cathode rays, right? And these cathode rays consist of these negatively charged particles, which are called as cathode, right? We will prove we will prove that these beam of electrons or cathode rays consist of negatively charged particles, right? Because today we know that electrons are negatively charged particles, right? And this is what we are trying to discover in this experiment, right? Because we know that since this is positive, this is negative, this is positive, right? And these invisible rays, which are cathode rays, right, which we called as cathode rays, since they are moving from cathode to anode, right, since they are moving towards this positive electrode, right, that means the electron or the particles in this cathode rays, right, are negatively charged. That is why they are moving towards positive electrode. So this proves that these invisible rays or the cathode rays consist of negatively charged particles, right, which we now call as electrons, right. So this lead to the discovery of electrons in the gaseous atoms. And one important thing in this experiment, that the flow of electricity or the electrons, right, in this discharge tube are produced first from the material of the cathode when high potential of 10,000 volt was applied, right, across this tube, right. This material of the cathode have started emitting electrons, which are these cathode rays, right. And when these cathode rays or electrons hit the gaseous atoms, right, when these collided with the gaseous atoms, they excited the gaseous atoms, right. When they excited the gaseous atoms, the gaseous atoms started emitting electrons, right, which are nothing but these beam of electrons, right. So electrons are coming first from the material of the cathode and then from the gaseous atoms. Gaseous atoms, how they are coming from gaseous atoms? Because when the electrons from the material of the cathode hit these gas molecules or the gaseous atoms, right, on hitting or on collision with the gaseous atoms, they, or what we use term is, when the electrons bombarded the gaseous atoms produced electrons, right. They got excited and they lost their electrons, which started moving towards anode, right. So electrons from the gaseous atoms also started moving towards anode. So we have electrons from two sources, one is gaseous atoms and the other is the material of the cathode, right. This is the Crooks experiment, right. Now there are some properties of the cathode rays, right. First is, since they are traveling in the straight line, right, so first is these cathode rays, right, these travel in straight line, right. How to prove that they travel in straight line? If suppose you take this kind of a tube, right, and if you have these cathode rays, right, like this cathode rays moving, and if you suppose you place some kind of an object, right, you will observe that you have a shadow. You will observe a shadow of this object like this, right. Since these cathode rays are producing image of an object that is placed in its path, right. So the formation of this image, right, of the object that is placed in its path proved that these cathode rays travel in a straight line, right. So this proves that cathode rays travel in a straight line. The second property is to prove that cathode rays consist of negatively charged particles. If we apply an electric field, right, across this discharge tube, right, suppose this is your negative end, this is your positive end of electric field, it is observed on applying electric field, the cathode rays will move towards or will deflect towards negative plate of the electric field. Since they are deflecting towards negative plate, so this proves that cathode rays consist of negatively charged particles, since they are getting deflected towards the positive plate, right. So this is an important property of cathode rays. And there are other properties as well, right. And similarly, if you apply, instead of electric field, if you apply magnetic field, then also this beam of electrons or cathode rays will deflect in a direction, so that shows that these cathode rays consist of negatively charged particles, right. So, and when these cathode rays fall on a metal foil, right, they produce a heating effect. So that means